Hello everyone. This video is titled Simplify Powers of I. And all the exercises that I'm going to be doing in this video are taken directly from a free online textbook at openstax.org. And it's their Intermediate Algebra Text, 2nd edition. And I'm in section 8.8 titled Use the Complex Number System. And I'll be working on exercises under the heading Simplify Powers of I. And I'll only be working on the even numbered problems, so number 470, 472, 474, and 476, just those four. You may notice that the odd numbered problems, you can click on a little link and you'll be taken to a part of the book where you can see the solutions. So I'm going to be working on the even numbered ones that don't have solutions in the book. I'll also have timestamps for each example in the description of this video. So example 1's timestamp will be number 470. Example 2 will be for number 472, example 3 for 474, and example 4 for 476. I also request that whenever I bring up a new question, pause the video and try to do it yourself before watching me doing it and comparing. Because if you're just watching me do these problems and not practicing yourself, chances are you're not learning all that much. Alright, so question 470, example 1, I have written these problems out. So you see here example 1 corresponding to number 470 in the text. And we're asked to simplify I to the 39th power. Right, I to the 39th power. Well, before I get into I to the 39th power, let's talk about the powers of I. Right, raising I to integer powers. So please recall that I was the square root of -1, right? The principal square root of -1, also called the imaginary unit, however you've seen it. So let's roll through some powers of I here. So I to the first, right? I to the first is just going to be simply I. Right? Just like most things, anything to the first power is itself. I to the 0 even fits with other properties you may have seen for exponents. This is a non-zero number to the 0 power. And you may recall that a non-zero number raised to the 0 power is always 1, and that is also the case here for imaginary numbers. Alright, then I squared, right, I to the 2nd power. Remember, I is defined as the square root of -1. So that means when you square I, you get -1. Right, so I squared is -1. Then I to the 3rd power. Remember, I to the 3rd power we can think of using properties of exponents as I squared times I, right? All we do whenever we increase the power by 1 is just multiply by I again, right? And you just said, right, we just saw that I squared is -1. So this is -1 times I, or -I. Okay. And then I to the 4th power. You could think of as I cubed, times I, or I squared times I squared, or I squared squared. That's I to the fourth if you think of your properties of exponents. So we have negative 1 times negative 1. Right, remember I squared is negative 1. Well, that's just positive 1. So look at this. I to the 0 is 1. I to the first is I squared is negative 1. I to the third is negative I. And then it starts over. It starts over. I to the fourth is 1. So what you're going to notice, and I'll do a few more powers of I here, but what you're going to notice is that this cycle from I to the 0 up to I to the third, this is a repeating cycle. Every 4 powers, these will repeat. And watch. So I to the fifth, right? If this cycle truly repeats, I to the fourth is 1. So I to the fifth should be the same as I to the first, which would just be I, and let's see that. Well, I to the fifth, right, is just I to the fourth times I. And we just said a second ago that I to the fourth is 1. So this is 1 times I, which is just I. Right, and look at that. So if this cycle is repeating, the next power of I should be equal to negative 1. So I to the sixth, right, should be the same as I squared. Well, let's see. That would be, I to the fifth times I, or I to the fourth times I squared. I to the fifth was I times I is I squared, which is negative 1. And then I to the third should be the same as I to the seventh, right? You just keep adding 4 to these powers and you get the same result. Let's see. See, I to the seventh would be just I to the fourth times I to the third. That's 1 times I cubed, which is 1. So yeah, I to the seventh is exactly the same as I to the third, which we saw earlier was negative I, whatever, right? Same 4 in a row. 1, I, negative 1, negative I. 1, I, negative 1, negative I, right? So then from I to the 8th until I to the 11th, it'll be the same values. Alright, so yeah, you just keep adding 4 to the exponent and you'll get the same result. Alright, so I'll put up a bunch of powers of I that are all the same on this next page, knowing this cycle. So starting with I to the 0, right? I to the 0 is the same as I to the fourth, the same as I to the 8th, the same as I to the 12th, I to the 16th, and so on. You could also go backwards. Keep subtracting 4, and you'll get the same result. So I to the negative 4 equals I to the negative 8 equals and all of these are equal to 1. Right. Then I to the first. I to the first will have the same value as I to the fifth, right? Just keep adding 4. I to the 9th, I to the 13th, I to the 17th, and so on. And also, again, you can go backwards. I to the first, 1 minus 4, I to the negative third power, I to the negative 7th power, negative 11, whatever. All of these powers of I are the same thing, and they're all equal to just I. Alright, and then I squared would have the same value as I to the 6th, right? Just keep adding and subtracting 4. Same as I to the 10th, the same as I to the 14th, I to the 18th, and so on, I to the 22nd. you can go backwards. Take I squared, subtract 4 from the power. So I to the negative second, I to the negative sixth, I to the negative 10th. All of these powers of I are equal to -1. Right. And then finally, taking care of the rest of the powers of I, we have I cubed. Right. I to the third power will be the same as I to the 7th, I to the 11th, I to the 15th, I to the 19th, the 23rd, the 27th. Going backwards, you have I to the negative 1st, I to the negative 5th, and so on, -9, -13, and whatever. All these powers of I are equal to -I. Right? But like I said, these 4 results are the only 4 results you get when you raise I to an integer power. You're either going to get 1 I, -1, or -I. Alright. So here's how we're going to simplify. Alright, so to simplify a power of I, express the power as 4 times some integer, say n, plus some remainder. Alright, maybe I should put 4q plus r, because q for quotient, r for remainder, when you divide by 4. And I want r where r is equal to either 0, 1, 2, or 3, right? Because I to the 0, I to the first, I to the second, I to the third, those are the ones that keep repeating over and over again. So r is 0, 1, 2, or 3. That's all you need to do, and I'll show you why after, when we go through the examples. So basically, you divide the power by 4 and express that power as 4 times the quotient plus, and I want the remainder, right? I want the remainder to be either 0, 1, 2, or 3, positive 1, 2, or 3. No negative remainders. Okay, so let me show you what I mean with this. All right, so back to the actual question 1 here. All right. We're asked to simplify I to the 39th power. Well, 39, this is 4 times 9, right? That would be 36. 4 goes into 39 9 times, plus 3. Right? 4 times 9 plus 3. So, I to the 39th power, you will see, is the same as I cubed, which is going to be -I. Right? Right? Because if you think about it, if you were to start at I cubed, and then you just have to add 4 9 times to get I to the 39th. So I cubed is in this same row as I to the 39th, which would be -I. Right, so and now the long way of doing this would be, I to the 39th is I to the 4 times 9 plus 3 power. And then you apply some properties of exponents to show that this is I to the 4th to the 9th multiplied by I cubed, right? Because this would be I to the 4 times 9, power to a power property, and then times I cubed would add 3, right? That's the product property. And remember, I to the 4th is 1. So this is 1 to the 9th times I to the 3rd, or just I to the 3rd, which is -I, right? I to the 3rd simplifies to -I, as we've seen. So I to the 39th equals -I when totally simplified, right? again, when you totally simplify these powers of I, you get one of four results. 1i, -1, or -I. But yeah, the key is the remainder. All right, the key is the remainder. I to some power will be equal to I to the remainder when you divide by 4. And again, the remainder is going to be either 0, 1, 2, or 3. And then you know how to simplify I to the 0 through I cubed. Alright, now I would also like to double check this. Alright, and I'll use a calculator. You've seen me do this in previous videos. I have a TI-84 Plus emulator that I'm pulling up here. Now notice on the top of the calculation screen it says normal, float, auto, and then you have A plus BI. Right, so most of you are probably in real mode right now. Change it, hit the mode button, change it from real mode to A plus BI mode or complex mode, so that way you can actually see square roots of negative numbers show up as imaginaries with the I imaginary unit instead of getting errors. And then we just enter I, which is above the decimal point. That's I to the 39th power. And this should end up being just -I. Great. And like I said, just keep adding 4 to that, subtracting 4 to that. I to the 43rd power would also be -I. Oops. I didn't put raised to the 43rd power. Sorry. I put I times 43. I raised to the 43rd power would also be -I, right? I raised to the 47th power would also be -I, right? Again, you can just keep adding 4 and subtracting 4 from that power and get -I. Wonderful. Alright, so it worked out. Alright, so next question, doing the same stuff. Alright. So I to the 48th. Alright, I to the 48th. Now 48 is a multiple of 4. It's 4 times 12 plus 0. Alright, the remainder is 0. And that's the key. Alright, so I to the 48th will be equal to I to the 0. Right? Just the remainder. Right? And I to the 0 is 1. Alright, so I to the 48th is 1. And that's it. And let's take a look. Right? Again, I'll pull my calculator up. And I'll enter, I to the 48th power and see that it's 1. See, it's 1 plus 0i. But plus 0i doesn't mean anything, right? It's like adding 0. So it's just 1. Same thing for I to any, keep add 4, subtract 4. I to the 52nd power is 1. Right? 1 plus 0i. I to the 56th power, 44th power, right? Any multiple of 4 is just 1. All right, wonderful. Okay, next question. Same instructions. All right, number 3, exercise 474. Same instructions. So what's I to the 162 power? So again, 162, this is 160, which is 4 times 40 plus 2. All right, again, I want my remainder to be 0, 1, 2, or 3. So I to the 162 power has the same value as I squared, right? Just the remainder when you divide by 4. And what was I squared? I squared is -1. Right? and that's it. One, it's either going to be 1i, -1, or -I. And then once again, since it's short, I'll check with the calculator. I raised to the 162 power is, see, the power is throwing this off, but look at this, don't be alarmed by this stuff. 3.8 e -12I. Remember, e -12 means times 10 to the -12. This is basically 0. And the reason this happens is because of the way calculators round. Like, calculators aren't perfect. So don't always, accept them with 100% faith, 3.8 e -12, this is basically 0i. So it's -1, right? This is really -1. Right, and the reason that happened is because of the high power of I here. I'll bet if I did a lower power of I, if I just did I squared, right, if I just do I squared, say -1 plus 0i, if I do I to the 6th, right, I to the 6th, -1 plus 0i, and I guess the higher powers get, the funkier the calculation gets, so that's why the rounding's a little off, but it should still have a real part, basically be -1 plus 0i, or just -1. Right, I to the 10th would be -1, I to the 14th, I to the 18th, right, I to the 22nd, all the way up to I to the 162 should be -1, right. Okay. So don't you don't always take the calculator with 100% faith. But it was basically -1 when I punched it in, so this is correct. All right. Final question, number 4, exercise 476 from the text. Same stuff, I to the 255 power. All right, well, 255, we're just going to think of how do I, divide it by 4? How many times is 4 go into 255? Well, this would be 4 times, now 4 goes into 25 6 times. Now if I just did 4 times 60, that'd be 240, so there's 15 left over, right? 4 goes into 15 3 times, right? So 4 times 63 would be 240 plus 12, that'd be 252, and I have 3 left over, right? Plus 3. The remainder is the key. Right? I to the 4th power is going to be 1, so this will all just be, when I raise I to this will be 1 times and then I cubed. So I to the 255 power is just the same as I cubed. Right? And we saw I cubed earlier. That's just I squared times I, -1 times I, or just -I. Right? And that's as simple as that gets, -I. Now once again, because the power is so high, it might have the little rounding problems, but let's pull the calculator up again and see. If I put in I to the 255th power, should just give me, 0 minus I. See, 5e -13, that's 5 times 10 to the -13th power. That's 0, basically. There should be 0 there. It's 0.00000, 12 zeros and a 5. Basically nothing. So really this is minus I, as I said. Right? It should just be minus I. But the issue arises because of this very high power of I there. Right, because if I do just I to the 3rd, right, if I do just I to the 3rd power, it's -I. Right? If I do just I to the 15th power, it's -I. Right? Just the higher powers get, the more involved the calculation gets, and some rounding errors happen in calculators, and but still it's just basically minus I. We are correct. Wonderful. All right, so yeah, so I to an integer power, the key is finding the remainder 0, 1, 2, or 3 when I divide that power by 4. Wonderful. All right, so hopefully watching me go over these 4 questions here help you in some way when you're asked to simplify powers of I on your own. And thank you very much for watching.